In this video lesson, let us understand regarding the combination of the two p orbitals of the two different atoms, which results in the formation of a molecular orbital. Now this case, let us understand regarding the overlapping of the two atomic orbitals of the p by sideways. So the case under discussion for this video is the overlapping of the p atomic orbitals in the sideways. The previous video we learned regarding the head-on overlapping of or the axial overlapping of the pz atomic orbitals. Then px and py atomic orbitals, which are also in dumbbell shape, their overlapping will not happen along the nuclear axis. Instead it happens laterally, which is what we refer by the name as sideways overlapping. Due to sideways overlapping, they result in the formation of pi covalent bond. Due to lateral overlapping or due to sideways overlapping, these atomic orbitals of the p, that is px and py, both of them will result in the formation of pi molecular orbitals. The pi molecular orbitals can be pi bonding molecular orbital or anti-bonding pi molecular orbitals. Now let us see how this happens. I have written here in the form of a diagram, depicted everything, just focus. This is the dumbbell shaped p orbital of atom A, and this is the atom B, p atomic orbital of the same energy level. See, for the molecular orbital to be formed, the orientation should match, energy level should match. What do I mean by this? If there is an overlapping between the atomic orbitals, it should match with energy level as well as the orientation. 2px atomic orbital will not undergo overlapping with 2py atomic orbital or with 2pz atomic orbital because the orientations do not match. Though energy level matches as a second energy level, but because the orientation does not match, such an overlapping will not happen. If it is an overlapping, it should satisfy two conditions. One is that it should have the same energy level orbitals to overlap. Another important point is that they should also have the matching orientation, same orientation. So therefore, the two atomic orbitals under consideration in this case is 2py of atom A, 2px of atom A is undergoing overlapping with 2px atomic orbital of atom B, and this is their nuclear axis. The dot, big dot here represents the placement of the nucleus or the nuclear axis. If there is an overlapping among them, they will undergo lateral overlapping, sideways overlapping. And as I already stated to you in my previous video also, in the dumbbell shape of the p atomic orbitals, one side of the dumbbell is taken to be the crest and other side is considered to be the trough. Now this can also be considered in a similar way. Say supposing this is the crest and this is the trough of this p orbital, and this is the crest and this is the trough of this p2p x orbital. Then the overlapping, if the crest and the trough overlaps, then we call such an overlapping as in-phase overlapping. As a result of this, the molecular orbital is formed by addition of wave function psi a plus psi b, and the shape will be like this. This is the region of the placement of the nuclei of the two different atoms, and the molecular orbital thus resulted. One side is written as crest and the other side is written as the trough. See, for practical purposes, we just represent the orbital like this without giving or showing this connection. See, like this. This is also okay for writing. Now, what is the name of this orbital thus obtained? This is pi. Why pi? I already told you the reason for this. Because the overlapping is happening. Overlapping of the atomic orbital is happening along the sides or the lateral overlapping. Therefore, we will end up in the formation of pi covalent bond and pi 2px. This molecular orbital form is the bonding molecular orbital because it is formed by the addition of wave function and it is possessing less amount of energy. So always when we write an arrow facing down, we are going to represent only the bonding molecular orbital there, the shape of the bonding molecular orbital, because as I told you, bonding molecular orbital always possesses lesser energy, lesser than even the atomic orbital. So while you write the diagram, you should take care to see to that atomic orbitals you write it at a little higher energy level and the antibonding much more than that, and the bonding should be written below like this. You should not interchange the order. That is not acceptable. Well, so one more way that they can undergo overlapping is that, say supposing this is the trough of this atomic orbital and this becomes the crest. So now who and who is going to overlap? The crest of atomic orbital A, 2px atomic orbital A, is going to overlap with the trough of 2px atomic orbital of atom B. That means there is out of phase overlapping. Here also the same case, here also the same case. So they definitely are going to result in the formation of the addition of wave function resulting in the anti-bonding molecular orbital. Because it is lateral overlapping, we need to write the pi symbol there. Pi asterisk indicates the anti-bonding molecular orbital and it is a molecular orbital of 2px energy level. So pi asterisk 2px indicates so many things inside that. Now, this is the location of the nucleus of A and B respectively. So we call it as the nuclei. Nuclei is plural, nucleus is singular. See, each side is represented with its wave function, that is the crest and the trough. Here the trough and the crest. So this is how the shape of the anti-bonding molecular orbital will be. Because these two nuclei between them, the electron density is quite less, they are repelling, so therefore the shape will be like this. Between the nuclei, the electron density is more, so they have an affinity, therefore the shape is like this. Another important point to be registered here is that it is found that 2px pi 2px energy level is equal to pi 2py energy level. Similarly, pi asterisk 2px energy level is found to be equal to pi asterisk 2py. Now, to write them diagrammatically, we should write like this. There are the p orbitals which are undergoing the overlapping. 3 of the p orbitals will be there. That is 2px, 2py, 2pz. 2pz case I discussed previously. Now in this discussion I am considering only 2px and 2py. So therefore, how many atomic orbitals are overlapping? 2px and 2px atomic orbitals of 2 different atoms. 2py, 2py of the 2 different atoms. So totally participating atomic orbitals is 4, 2 from each. So therefore, the molecular orbital form will also be of the equal number. 2 bonding molecular orbitals, 2 anti-bonding molecular orbitals. How will be their energy level? The energy level of sigma 2px would be equal to the energy level of, pi 2px would be equal to the energy level of pi 2py. That means the bonding molecular orbital formed by X and Y of the same energy level will have equal amount of energy. If second energy level 2px is undergoing lateral overlapping, similarly second energy level 2py atomic orbitals are also undergoing lateral overlapping. The resulting bonding molecular orbital out of that will possess same amount of energy, which is why we need to write these two boxes. One is representing pi to px, another is representing pi to py. Why are we writing it in the same level? Because they possess same amount of energy. So here when we fill in the electrons, care should be taken to see to it that we follow Hund's rule. That is a must. Now similarly, as I told you here, we need to apply that here also. One is the bonding molecular orbital, other set is the anti-bonding molecular orbital, which is shown with an asterisk sign. So pi asterisk 2px energy level, this orbital energy level would be equal to the energy level of pi asterisk 2py. Though the orientation should match, the resulting orbitals obtained by matching energy level and matching orientations, the energy level will be the same. So here also when we need to fill in the number of electrons, we definitely need to apply Hund's rule of maximum multiplicity. Let me just give you an example. Say supposing in a case example, we have the 3 electrons to be filled for this. Now how will those 3 electrons be filled? First electron here, second electron should go in there, and the third electron will come in here. Instead of writing like this, we should not straight away write 2 here and there 1. Why? What is the reason? The filling will not happen like that because it has to follow Hund's rule. Say supposing there are 6 electrons. How will be the filling? 1, 2, 3, 4, 5 and 6 should not be written in here, the same orbital. The 6th electron should come here because they are the molecular orbitals possessing same amount of energy. We need to apply Hund's rule of maximum multiplicity without fail. Now, how will be the diagrammatic representation for 2py overlapping as I have represented here, 2px overlapping? How will be the case for 2py? Exactly in the similar way, the molecular orbitals obtained will also be like this. Only thing that we need to change is that this atomic orbital which is orienting along the x-axis should be slightly tilted and should be written for orienting along y-axis. Both these atomic orbitals need to be written in that same fashion. Okay. So, now in detail we have understood about the lateral overlapping or the sideways overlapping of the 2px and 2py atomic orbitals resulting in the corresponding molecular orbital bonding and anti-bonding respectively. Similarly, in the previous video we also learnt regarding the axial overlapping involving the 2pz atomic orbital. Axial overlapping everywhere results in the formation of sigma bond. Lateral overlapping everywhere results in the formation of pi bond. So accordingly we need to write as sigma 2pz, sigma asterisk 2pz to indicate the difference between bonding and anti-bonding molecular orbitals. Here also pi 2px, pi asterisk 2px and pi 2py and pi asterisk 2py, all of them are formed by lateral overlapping. And one important point to be registered here is that the energy level of pi 2px atomic orbital would be equal to pi 2py. Similarly, pi asterisk 2px atomic orbital energy level would be equal to pi asterisk 2py. So, with that we have understood regarding the overlapping of the different p orbitals, which is resulting either in axial or lateral overlapping. The next video lesson I would be covering in detail about the molecular orbital electronic configuration, about how to write this, how will be the final energy level diagram, all that we'll discuss in detail. And to make you to understand the concept, I will also be discussing case examples in different videos. Watch all of them for a deeper understanding of the concept. Hope this video helps.